Hi, I'm Siddharth Talur, and this is Thinking in Love. In today's episode, I want to talk about three personal stories, all of which deal with research projects that I undertook at different stages in my career. But I will talk about these stories where I took different responses to challenges that I faced. Let me begin with the first one, which is from the time I was doing my PhD at Cornell University. When I joined my PhD, I wanted to work in circuit design. I joined a group with whom I had worked a couple of years before I started my PhD as an intern. And for the first semester, I enjoyed the work that I was doing. But I was starting to feel that that was not the kind of work that I would eventually want to do in my PhD. I wanted to do something creative, something new, where I would have the sense of satisfaction of doing some intellectual problem solving. So then I switched and started working on this other project in another group. This was a very different area. This was MEMS or micro electromechanical systems. What this area is where you take chip fabrication techniques, so the same techniques that you use to make semiconductor chips, but those techniques are used to make moving parts on a wafer. So the same wafers that are used in circuits, you make elements that would move. Now, these kind of things are used in our cell phones. These are what go into our accelerometers or gyroscopes, microphones, a lot of sensors, a lot of products in our daily lives use these MEMS sensors. So I started working with a group where we were making MEMS devices, and my project was one where I had to use light as well. So along with using electrical signals to cause motion in these devices and detect that motion, do some things with that motion. My research also focused on using light. So I had to somehow introduce light into these devices and then also use light to measure the motion of these devices. So the project that I was working on was one where we were causing vibrations of these devices. So these we called oscillations. So you cause the device to vibrate freely at some frequency that you design for. So like a bridge, when a car passes over a bridge, the bridge vibrates at a certain frequency. So that frequency depends on the design of the bridge. Similarly, you can make these micro machine devices in a manner where you can control the frequency. So you design them in a manner where you know what the frequency is, and then you use light to basically generate motion, and then the light is also used to measure the motion. So this was my project, and I started working on it. But I worked for a year or so, but nothing was working. I was making devices; they were expected to be moving. I mean, everything looked, at least visually, looked perfect the way I intended them to be. It took some problem solving to get there, but a year into the project, at least visually, things looked okay. I take a picture and you wouldn't be able to tell that there was any problem with the device. But then there was no motion. I was trying to generate these vibrations, but nothing was happening. All the experiments that I was trying, I knew the experiments, the way I was doing them, there was nothing too wrong about that, but it just did not seem to work. So anyway, I kept trying, and nothing was happening. So I was reaching a point where I was very, very frustrated with that work. I just didn't know if there was any point in continuing that anymore, whether it will even be successful or not. Right? This was, of course, I mean, research is an idea, and you, when you start working, don't fully know whether whatever you have in mind will actually pan out the way you imagined. You have to try and find out and solve problems along the way. But this was a project where I tried whatever I could think of. All the ideas that I could think of, I had already tried, and I was completely out of ideas. So I was at a point where I felt that I have invested enough time on this, and maybe it's time to stop and look for something else. So one day I decided I'll just go talk to my PhD advisor and tell him that, look, I've tried all these things, this doesn't seem to be working. Whatever we had in mind may not be, I mean, we may not be on the right path after all with whatever we were thinking, so maybe let's think of something else. So that's what I was thinking. But before I went to meet him, I thought, let me just get some more data because I had made a lot of chips at Cornell where I was working. So I thought, why don't I gather data on all these chips that I've made so that he at least cannot tell me that, hey, look, you haven't tested all these things that you made, why don't you go and try it again? So I went to the lab once more to do some more experiments and get data. But then I wasn't expecting anything to work. So my goal was to just get through that very quickly. So I thought I'll take a shortcut. I wanted to just get done with those measurements very quickly. So I was using this instrument called a spectrum analyzer. So anytime you have this device that vibrates, and like I said, you use light to measure those vibrations. So you can use a light detector, a photo detector that converts these signals into electrical signals. And a spectrum analyzer is something that you use to measure the frequency of those signals. So if there are oscillations, if there are these vibrations, you would see that on the spectrum analyzer. So I thought I'll use the spectrum analyzer. And a spectrum analyzer has a functionality called as max hold. So you can program it to be in a max hold state, and you can keep doing some experiments. You can keep applying signal. You can try a few things with your devices, and this spectrum analyzer in its max hold state will just show the maximum value of the signal on its screen whenever that may happen during the course of your measurement. So let's say you did some setting which caused some vibrations, maybe it will just show up as a maximum signal there and it wouldn't get erased. That value just gets saved on the screen. So I thought this is a quick way for me to just go through all these chips that I've made, and I wasn't expecting any signal to show up in this max hold. So I thought, why should I just go through this very carefully? And instead of slowing down these measurements, maybe I'll just use max hold and just apply a sweep. So I'll just um, take my laser, which I was using for applying the light, and just change its wavelength. So I'll start from the lowest wavelength and just keep turning the knob and take it to the highest wavelength that I wanted to apply. And anyway, I was expecting on the spectrum analyzer, I'll not see anything. And then I can move on to the next step, do this very quickly. So that was my plan. So I started doing this. This is not how I would do all my experiments earlier. I was much slower. I was taking care to slowly change the laser wavelength. But then in this instance, anyway, I wanted to save time, so I tried this shortcut. Now, what was surprising was that when I did my experiment this way on the same devices, I saw that every single one of them was showing me vibrations. That was not what I was expecting. I went in there to do this experiment so that I can save some time and quickly just gather all that data, show that this full thing is a failure, and ask my advisor for a different topic. But then I saw that every single thing that I had made, and I was testing, maybe for the last whatever 2 or 3 months, was actually working. I was not testing it correctly. So later, what I found out was that there's something called as a quality factor. So these are energy storage elements, right? Like I said, they have vibrations at a particular frequency. So these are what we call as resonators. It's like a spring. So you pull a spring or compress a spring it tries to go back to its original shape, right? So it stores a lot of energy, which then tries to release. So it's like the same thing here. But these things were like very good energy storage elements. So to couple energy into them, so if I have to get light to go into these devices to actually generate those vibrations, because they are such good energy storage elements, it is difficult to take energy out of them, and it is equally difficult to couple energy into them. So the way I was doing my experiments earlier, where I was slowly changing the laser wavelength, that was not the right way to do measurements on such devices. But what I did later, which I thought was a shortcut just to save time and show that these things were not working, that in fact was the right way of doing my experiments. So that was quite something, right? That was not what I was expecting. I was facing a research problem. I was on the verge of giving up. But then what I realized was I just had to change my approach. I didn't have to keep banging my head on the same wall and just keep trying the same things again and again, hoping for a different outcome. I just had to do things differently. So that is my first story, where there was a research problem, or let's say there was a problem, and what it took to solve that problem was just changing my approach, but not giving up. I did not need to change my path. That same research question that I was working on, I continued working on that same theme for my PhD. And eventually, I had a very good PhD. I got a lot of interesting research done. So I did not need to change my focus area. So that's the first story. I would say the moral of the story was that sometimes when you face problems, what you need to do is just change your approach. Maybe you look at the problem in a different light, and that's what it takes to solve things. Let me tell you my next story, but this one maybe let me keep it brief. This story is from when I moved back from the US. I was working at Analog Devices. I was working on similar MEMS products there. Like I said, accelerometers, gyroscopes, these are all MEMS sensors. I was working on making MEMS sensors in a team that develops such products at Analog Devices. And when I joined IIT Bombay, when I came back to India, my plan was to continue working in the same area. I had a few ideas which I thought I'll execute here as I start my research program. So I joined this institute, and I slowly started getting a feel of how it is like to work here. I mean, if you have research ideas, you want to use the research labs to get all these things done. What actually does it take? What um, processes you need to go through? Because these are not labs where you, as an individual, get to decide things. These are shared labs. So then there are policies that are formed, and then it's very difficult to introduce any new policies if the existing policies are not designed in a manner where whatever plans you have, you can get to execute them. So all of these things I was figuring out after I joined. Before joining, I had some idea, but then you once you are in the situation and getting a first-hand experience of things is when you really know what it takes to do something. So without going into details, let me just say that what I learned was that many of the ideas that I had in mind would just be very, very impractical to pursue in this system, right? I mean, with the given set of rules and the policies and the way things are done, it was just very, very difficult to execute the ideas I had in mind. I would need a lot of patience. I would need to work with the system and kind of need to adapt my ideas, but that was too demanding. I mean, of course, the earlier story that I mentioned did not need me to change my focus. I mean, the focus remained the same. I had to change my approach. But then in this instance, I was not sure whether my focus would survive, whether that would remain the same, or I would. have to just endure a lot of trouble just to make that happen. So then I started thinking that, hey, when I started doing my PhD, I was actually working in a different area. MEMS is something that I started working on because whatever I was doing earlier when I was doing circuits, I wasn't getting that satisfaction. So I started doing MEMS because that presented an opportunity to satisfy that intellectual curiosity that I had at that time. And my career trajectory just took that path from there on, and that's how I started doing MEMS. But this was not a area that I was devoted to or something that I've spent decades on, and therefore, there should be this some sense of commitment for whatever reason. I mean, it was an area that allowed me to pursue my interest for some time. So maybe now is the time where I have to make a change, because sticking with that area is brings so much trouble and so much pain, which I felt was not worth it. Right? I need not endure it to try and change a system uh, just because of some sense of commitment to this area. So then I started thinking, what else could I do? And systems level research was something that I was also curious about. I got to do a little bit of systems development when I was at Analog Devices in the same team, because making a product requires you to look at different aspects of the problem. You cannot just look at, let's say, MEMS design and say that I'll not worry about packaging or circuit design. I mean, you have to try and understand all aspects of the problem. I had some experience of that, and I felt I was good at it. So I said, okay, why not try maybe that same approach with my research? Why should I stick to only MEMS ideas? Let me entertain some systems level ideas. So two areas that I had in my mind. One was the structural health monitoring, which is the area where we focus on in our startup that we just started. And the other area was biosensing. So I was very curious about biology. I never got to work in that area before. I thought, okay, let me use this opportunity, strike up some collaborations. And good thing about IIT Bombay is that everyone, or most people, are very, very collaborative, very easy to discuss and interact and kind of work together with. So that's how my journey started from there on. So I consciously changed my research area. I gave up doing MEMS and started working in these other areas, which are the main areas my research group now focuses on. So this was my second story. This also talked about a problem I faced in my research, but the moral is very different from the first story. In this story, my response was to give up. So I felt the problem was not worth pursuing anymore. I mean, it was just not worth the trouble trying to solve that problem. So I just gave up on that problem and started doing something else. And that was also very rewarding. So in the first story, I persisted, changed my approach, I persisted. Turned out to be very rewarding. In the second story, I gave up, also turned out to be very rewarding. Now, let me tell you the third story, which is something I'm going through right now. So, this story has not yet ended. This is related to the biosensing work that I just mentioned. So, I started doing this work more seriously in 2020, once the COVID 19 pandemic was in full swing. There were many other projects done in this area, but one of the more successful ones, which we've continued working on since then, was where we try to make these sensors to detect nucleic acid, so DNA or RNA of microorganisms from sewage water. So this work we started doing because in COVID-19, um, this has been proven. I mean, even for polio, this is true. This is how polio surveillance is done. Of course, polio is eliminated from many countries, but then there are a few cases, so you have to keep checking for polio so that any cases can be immediately addressed to. Otherwise, disease which has been eliminated from a certain country can come back. Right. So even in India, this is done. What is this? This is wastewater surveillance. So you look at sewage water because if you have any infected individuals, anyone who's infected with, let's say, polio or COVID-19, they would shed the virus in their waste. And that waste then makes it into the sewage system. So then, from the sewage water of a community, if you find the virus in there, you know that in that community there's someone who is infected, and then maybe you can do active case finding. So instead of testing every single person living in a particular area, or well, living in every area, you can first narrow down which areas maybe the disease might actually be present in, and then see how do you go about doing some targeted testing. So this is a very nice technology because it reduces the amount of testing that you have to do. Instead of testing a lot of people, you test maybe some sewage samples from that community. So we started working in this area, and there are a lot of interesting research questions that we are looking at. So, from a research curiosity perspective, intellectual satisfaction perspective, it has been extremely rewarding. And this is a new area. Never in my life I had done biology before this. So, personally, this has been a very, very satisfying experience. To set up a lab where we do biology experiments, I never imagined in my life that I would be leading such a lab. So, it was a big confidence booster as well, and also very satisfying because the kind of research we've done is actually very nice. I personally am very, very satisfied with this. Now, this area has one problem. Um, Unlike sensors that you would make for individual testing, so in COVID 19, all of us use these rapid test kits and so on. Unlike those kind of tests, which can be sold to individuals directly or indirectly, I mean, either you sell it directly as a test which you and I could buy off the counter, or maybe you sell it to healthcare agencies or primary healthcare centers or whatnot. So you sell it to the healthcare system, and that makes it available to people. But you are selling whether directly or indirectly to the end user. Also, there is scale. So if you work on such technology, you could deploy it at scale. So there is a lot of commercialization potential. But what we were looking at were sensors for testing wastewater, sewage water. So for our technology, the end user is not an individual like you or me. Our end users are government agencies, and typically what we will deliver to them are bad news, right? So we'll tell them there's some disease present in your community, or maybe you're not doing enough work in eradicating something, and so on. So we deliver bad news. Never a good place to be in when you develop some technology, right? So getting funding, getting traction for our work, getting recognition, all of those are then challenging. Um, I'm not saying that one should do work only to get that recognition, but beyond a certain point, it becomes very difficult to sustain these experiments, sustain that research if you cannot gather all these resources. So that is something I'm going through now. I have found some solutions that let me continue that work with minimal resources. So going through such a problem makes you extremely disciplined. You plan very well, you execute plans very well, you don't use a lot of resources, you don't waste a lot of resources. So that discipline has been a good kind of side effect of having to go through this problem. But unlike the other two stories that I told you, the first one where my response was to persist, the second one where my response was to give up. Here, my response is one of adapting. Uh, so what I'm realizing is the kind of research that we do, it's not highly customized or very very limited to only wastewater or sewage water. That same research is equally applicable to individual level testing, the kind of things we did with those rapid antigen tests and whatnot. So here my response is one of adapting to the problem. So why wastewater? Again, I mean, like I said earlier, I was not married to MEMS. There was no reason to keep banging my head on the wall and do MEMS at any cost. Here, instead of abandoning that whole research pursuit altogether, I am asking why wastewater? Wastewater was an opportunity during COVID 19. We did a lot of good work. Maybe it will have relevance in other areas. If anyone is interested, they can reach out to us. I'm very, very happy to interact and engage. But I have tried doing so myself, and there are very few takers. So then, why should I stick with wastewater? Why don't I take my ideas and apply them to other problems where maybe people care? Maybe infectious diseases, right? So sepsis is something that I'm thinking about now. Um, Wastewater is a very complex sample. There are a lot of things in wastewater. I mean, you can imagine it's sewage water. Similarly, blood is a very complex sample. Blood has a lot of things. If you're trying to look for bacterial infection in blood, which is what sepsis is, bacterial, fungal, I mean, there could be many causes of infection. Um, to me, at a certain level, it's like looking for the same pathogens in wastewater. Wastewater has its own challenges. I'm sure working with blood also has its own challenges. But I have that level of confidence that if I could solve those challenges in wastewater, I can solve those challenges working with blood as well. So this is, like I said, this story has not yet ended. This is something I'm going through. So here my response is very different. Here I'm adapting. I am not giving up. Neither am I persisting. I'm doing a combination of both, you could say, where I'm giving up elements which I feel are not worth it, but I'm taking what has worked and adapting that maybe to a different problem where I think the same technology can have much bigger impact. Right. So I don't have any deep insights as such other than these three stories. I just thought I'll narrate them out in the raw form. Um, Similar situations where something you are going through, a research question you started with, or a research problem that you started with is not working out, but three very different approaches. The first two have already panned out. I know the ending. The ending has been rewarding. Let's see what the third one has in store. I am very confident that this will be rewarding as well. Maybe we will know a year or so from now. So let me stop here. I hope these stories were interesting. Maybe you are going through problems of your own. I'm sure you have your strategies for solving them. But remember, giving up is a solution at times. So is persisting, so is adapting. Each of them are okay. There's no shame in giving up. There's no glory in persisting. And at times you have to adapt. You have to use your individual judgment to figure out which solution you would take up at which point of time. That is something you have to decide. You should not get influenced by what others feel or others say to you. Take their inputs, but decide for yourself by yourself. So I hope maybe listening to these stories would have at least given you some different perspective. And maybe if you're going through a problem now, it will help you look at that problem in a different light and maybe find a solution if you are not there yet. So let me stop here. I look forward to meeting you in my next episode. I'm Siddharth Tadur, and this is Thinking in Love.